This is our 5th TOK video, and today we're going to look at reason as a way of knowing. So a little bit of introduction. Why do we care about reason? Well, it's through reason we can acquire knowledge about the world that goes beyond the evidence of our senses. Our sense perception is only going to take us so far, so we have to figure out what our senses are telling us. We have to fill in the gaps. Sherlock Holmes is the world's most famous literary detective, and so in all of his cases he's using logic. He uses what he can see, and then he fills in the gaps. He tries to figure out what the pattern is. For example, the sidewalk is wet. I didn't see it rain last night, so logically it rained last night. Even though I didn't see, all I have is the evidence of something that happened before. So this gives the knower certainty that something happened, regardless of personal opinion or culture. This is beyond humans. This is really just looking at the patterns. So how do we create logical arguments? We start with presumptions or premises. And these are assumptions on which an argument is based, from which a conclusion is drawn. And these are often based on other ways of knowing, other and most common sense perceptions. For example, here we have Socrates. There he is. And Socrates. In the case of Socrates, one premise: all men are mortal. Premise 2: Socrates is a man. Therefore, conclusion: Socrates is mortal. And then we see some diagrams to kind of show this, that the Euler circle I liked in this. Here's all mortal. Here's men who are mortal. And then here's Socrates, who is within that men category. And so we can diagram this out to make it a little bit easier to understand for us. Rationalism is a school of thought which says that reason is the most important source of knowledge, that everything else can fail us, that senses and emotion are not great ways of knowing. Whereas logic is pure. So math, in this case, is pure logic and has a high level of certainty. 2 and 2 is 4. It doesn't matter about the variables, it's going to be 4. And a lot of mathematicians are just focused on just that pure logic. You don't need sense perception or emotion. It's just the logic, and it's always going to make sense. We have the patterns, and they're set up, and they're ready to go. René Descartes, right up here, we'll talk more about him later, is the main master of logic and the guy that pushes for logic above the senses. And he believes that the only thing that we can prove, because the senses fail us, is that we have brains, that we can actually think on our own. The idea cogito ergo sum, I think therefore am. The only thing you can prove is that you are thinking. As far as your senses, they can fail you. We're going to look at 3 types of reasoning: deductive, inductive, and informal. And throughout class we're also looking at fallacies. These are invalid or illogical patterns of argument. So let's start with deductive reasoning, where we're starting big and we're going to work our way down to a singular conclusion. And this is reasoning from, again, general to the particular. And you can use a syllogism to do this. This is a deductive argument with 2 premises and a conclusion, where we're just chipping away until we can get to our final conclusion. And we're looking for valid arguments. This is the property of an argument in which the conclusion follows logically from the premises, regardless of their truth. And so we can have solid logic even if our premises are absolutely false. The pattern can be a good pattern regardless of the variables that you use. Example: all panthers are green. False. Mr. Ushery is a panther. False. Mr. Ushery is green. False. All those premises are false. However, the logically that makes sense, assuming that it would all be true, but it's not. And so the structure of arguments, if it is valid, you can plug in any variable in regardless of their truth, and we can analyze that. And so you can use that as, when it comes to truth, you can look at truth tables to kind of play with this idea where true and true is true, but true and false could be true, false and true could be true, but false and false, that's going to be false. So we can break down arguments like a mathematical formula. All A's are B's. Some A's are C's, therefore some B's are C's. And we can plug in any variable, and it's still going to be logical regardless of its truth. And so we can use diagrams or tables to understand whether or not an argument is valid, regardless of the truth. We're going to need these other ways of knowing to plug in to logic. Whether or not those other ways of knowing are true, that's on them. The logic should stand on its own. These equations should stand on their own. And deductive reasoning should preserve truth of whatever other data you're inputting. If premises are true and the argument is valid, the end result will be true. Enthymemes. These are incomplete arguments in which one of the premises is assumed but not stated. So we don't always include in our normal conversation some things we can skip over because we don't have to lay out the argument in every single detail. And so Jane went to Harvard, so she must be smart. We kind of skipped a step because it's a common assumption that if you go to Harvard, you're smart. And so the full one would be Jane went to Harvard, people that go to Harvard are smart, therefore she must be smart. And so enthymemes, we kind of skip a step just for casual conversation. Moving on to inductive reasoning. And this is where we start small and make assumptions about the larger picture. And so we move from what we do know, the observed, to the unobserved. Example, the sun rose yesterday. I saw it. So the sun will probably rise tomorrow. I haven't seen it, it's unobserved, but I can make a prediction based on, logically, it makes sense, this pattern has kept going, so it's probably going to keep going. And so why use one or the other? Well, deduction is more certain, but much less informative. Whereas, as far as deduction, we're looking at the past and looking at patterns of the past. Whereas induction is more informative, but less certain. Induction, we're making a lot more predictions based on present evidence. And so we can use both of these. One is not better than the other. It's how you want to use it, what you want to know. Studying the past or studying the future and making predictions, it depends. Inductive reasoning does require generalization, so it's a little trickier, it's a little bit harder to be made, leading to false assumptions based on my own bias. If I'm starting small and trying to figure out how it connects to the big, my own thinking may be false based on what I believe. And so it's this cognitive bias is irrational judgment due to our own subjective connections to a topic. A good example is belief bias. Thinking an argument is valid because we agree with the conclusion, and that I really like that idea, and so I'll come up with anything to prove it, even if it's a bad argument. And so if we follow the rules of structured arguments, we can avoid these cognitive biases. So if I'm doing research on dogs, I'm going to have to make certain assumptions in that research. So I want to follow certain rules to avoid bad reasoning, to avoid bad generalizations. Numbers. One example of a thing shouldn't be enough. One swimming dog doesn't mean all dogs swim. Variety. One type of a thing shouldn't represent all types. I want to look at age, breed, sex, all these different factors when it comes to my swimming dogs. Exceptions. I want to look for counterexamples. I want to find the dog that can't swim. And if I can't find the dog that can't swim, maybe I'm right. So I want to look for those counterexamples to disprove my theory. Coherence. Surprising claims require more evidence than common ones. One surfing dog would require a whole lot more research because it's such an outrageous thing. And then subject areas. Certain areas of knowledge allow for more generalizations. Natural sciences allow for tons of generalizations because we have patterns set up. And we can use those patterns. We can make those assumptions over and over again because it's worked in the past. Whereas human sciences, it's a lot harder to make generalizations because what works in one brain may not work for another brain. We're just too complex, and so we can't make as easy assumptions in certain areas of knowledge. Informal reasoning, our third round. Informal reasoning is useful in everyday conversations and especially debates, especially those political debates. And we want to avoid those logical fallacies in our everyday conversations, but also our arguments to make all of our arguments a little bit stronger. And so here's some examples of some of the ones we've been looking at in class, like ad hominem is a fun one, where you don't look at the actual person's argument, you just say, oh, you're ugly, therefore your argument's invalid. Causes of bad reasoning. 4 reasons why people reason poorly. One, ignorance. They just don't know better. They haven't studied any logical fallacies. Laziness. They don't want to put the time and effort into making better arguments. Pride, in that they have already dug themselves in too deep. And prejudice. They just have all those cognitive biases and they don't want to let go. And so either they don't know that they're wrong or they're unwilling to admit that they're wrong. In all debates, we're going to be using the art of rhetoric, in that it doesn't matter who is the most logical, it's who is the most convincing in an argument. So you need more than logic. And this is where emotion is going to be a powerful tool to get people excited about a thing, to get them to agree with you. And so just being right is not enough to win. It's being right, but also being passionate. You need a bit of the both for rhetorical power. And then rationalization, the manufacturing of reasons to justify your pre-existing belief. And that even if you already believe a thing and you don't want to let it go, you're going to come up with emotional ideas that just may not be logical. So looking at the big picture, how certain, how useful, how right is logic, we have to have a few assumptions. So laws of thought. These are fundamental assumptions on which logic is based, such as the law of identity. If A, then A. If something is a dog, then it's a dog. If we're talking about dogs, we should only be talking about dogs, unless there's some new thing. The law of non-contradiction. Nothing can be a dog and not a dog at the same time. That we are assuming that something is or is not. And law of the excluded middle. Everything is either a dog or not a dog. We can't come up with these other cases in between. And so as long as we have that, everything should logically make sense, unless we come up with some new thing like a hybrid dog-cat that messes up all of our arguments. And so we have to make certain kind of black and white assumptions for all these formulas to work. How good is logic? How certain is it? Well, there are some problems with logic. It's not perfect. If it was perfect, we would just throw away the other ways of knowing, but it's not perfect. Logic may be just how we think, not necessarily how the universe is. So we're going to use a bit of faith to believe that our thoughts are connected to reality, that because we think it's logical, then it is logical. It may not be. And 2, logic depends on language to place things into nice, neat categories, in that certain languages are going to have different definitions of things. And so language is absolutely necessary for logical reasoning. When does night end and day begin? Do we only have one word for night, one word for day? Is there something in between? Instead of A and B, there's a C all of a sudden. So sometimes language is going to be an important factor. And then if all things in this state of constant change, you are constantly changing, and the world is constantly changing, then no logical patterns can exist because you are not the same you from yesterday. And my study on dogs is different because it's a different day and there's now new data, so it's hard to find a pattern if the data is always coming in. How about inductive reasoning? What's the problem there? Well, there's assumptions that past patterns will continue in the future. That cannot be certain. We don't know that the sun's going to rise tomorrow. Logically, that's been the pattern, but we are not certain. And so even if something is a logical pattern, you can't be 100% certain. However, if we doubted everything at all times, we would drive ourselves crazy. Looking at, is my car going to work? Is fire hot? Is the sun going to rise? We're going to go nuts going through every little thing. So we have to make certain assumptions just to exist and be sane. Lateral thinking. So this is thinking outside the box. Because sometimes we can get stuck in a certainty trap, a logical trap where we're only looking at A plus B equals C. 2 and 2 is 4. 2 and 2 is 4. And this answer is the answer is asking in a different way. And so sometimes logic is limiting. And we need to come up with a new way of thinking that may be illogical. And thinking outside the box. And so it's useful when that traditional logic fails or we're trapped. We're going to have to come up and move outside of logic for a solution, or just a different logical puzzle. And that's all we have on logic for today.